Well, I'm going to talk about kinematics of mechanisms. This is a part of your syllabus theory of machines or kinematics and theory of machines subject. So let us start. First of all, you should know the fact that why you are studying this subject, kinematics of machines or theory of machines. Then the reason is theory of machines and mechanisms is a branch of engineering science, and it is studied to understand the relative motion between the parts of machine and the study of forces which act on these parts. So in this subject you will be studying what is the relative motion between the various parts of the machines and the forces which are going to act on those parts of the machines. How do I classify it then? See, theory of machines is actually classified into two main branches, which is kinematics and dynamics. Dynamics is further classified as statics and kinetics. So let us see all of them one by one. First of all, if I talk about kinematics, then kinematics is the study of relative motion between the parts of machine without considering the forces which produce that motion, right? So basically in kinematics we are just going to study the relative motion between the parts of machine. You can also say that in kinematics we are going to actually study the position of the link, right, or a part, which we say we will study what would be the displacement. We would also study what would be the velocity or a relative velocity of a part with respect to another part. We can also find out what would be the acceleration of the machine parts. So basically, kinematics is the study of position, displacement, velocity, acceleration of machine parts. Next, moving ahead, after kinematics, the next branch is dynamics. Dynamics is the study of forces acting on the various parts of machines and the motion resulting from those forces. So basically, we'll study the forces acting on the various parts of machines and the motion resulting from those forces. Dynamics is further classified as statics and kinetics. So statics is the study of forces acting on parts of machine when the parts are at rest, right? Statics, we are talking about statics. So the parts are at rest. The mass of the parts is assumed to be negligible. Moving ahead, after statics, it is kinetics. So kinetics is basically the study of inertia forces which arise from combined effect of mass and motion of machine parts. So whatever you studied before in statics, that the parts were at rest and mass was negligible, now we are also going to consider the motion of the parts as well as the effect of mass. So basically we are going to study the inertia forces which arise from combined effect of mass and motion of the machine parts. So this was the classification of the subject theory of machines or kinematics and theory of machines that we saw. Moving ahead, guys, why kinematics is important for us and why this particular topic we are discussing, kinematics. Kinematics is basically the motion study, right? So we are going to actually study the position, displacement, velocity, acceleration of different parts, different links, different elements of the mechanism. So if there is a certain input, then what would be the desired output that I want? That is the study of the kinematics. Let us say if I move crank by a certain, if the crank rotates at a certain angle, that is my input, then what would be the relative velocities of the other parts of the link? That I can get as the desired output. So basically, kinematics is the motion study. It is the study of position, displacement, velocity, and acceleration of the different parts of the mechanism. Moving ahead. In your university exams, many times the question is asked, define link or element, or define kinematic link or kinematic element. Link or element is one and the same thing. Different names are given. So guys, any body is usually a rigid body we think of about. Even if it is not a rigid body, it must be a resistant body, right? So any body which has relative motion to another with respect to some another body, right, that is called as the link or kinematic link. Let me briefly explain you. See, a component or a part which moves relative to another component or part is called as the kinematic link or element. Like I said, element or link may be or may not be a rigid body, but it must be a resistant body, right? So this characteristic you should understand, that your kinematic link should be a resistant body, should not get deformed easily when the forces are applied on it. A rigid body is that body under the action of forces, it does not undergo any change in size or shape, right? But a resistant body is that body which is capable of transmitting the required force with negligible deformation. So it should be able to transmit the required force without getting deformed. That is our resistant body. A link actually has following characteristics. Like first one, right? It should have relative motion. A link should have relative motion. And second characteristic is that it must be a resistant body. So if I talk about any engine like reciprocating steam engine, then steam pressure applies forces on the piston, and because of that, piston reciprocates inside the cylinder. So crank is connected to piston through connecting rod. So this reciprocating motion of piston gets converted into the rotating motion of the crank. So see how the relative motion is happening, and the because of that, the forces which will be generated, that forces will be taken by these resisting parts which we are talking about, like crank, connecting rod, piston, cylinder, right? So this is what is called as kinematic link. I would again like to define what is a kinematic link, since it is asked in your university exam, so you should be able to define it. We call it as a component or a part has a relative motion, right? It has a relative motion with respect to some another part or component, then it is called as kinematic link or element. So ये जो word kinematic है, it is directly related to word relative motion. अगर सिर्फ link और element है तो हम उसको part बोल सकते हैं. We can call it as a part. But when the word kinematic is added before the word link or element, then it means that one part moves relative to some another part. That is called as kinematic link or element. Now moving on, guys, to the types of link that you are able to see in the diagram. You can see over here diagram A, B, and C. You can see that those diagrams. So those diagrams are basically binary link, ternary link, and quaternary link. Right now, what is this binary link, ternary link, and quaternary link. You can see here, binary link, I can connect here with some another link, as well as I can connect this portion with some another link. So binary link is that link which is connected to other link at 2 points. You can see this is point number 1 and this is point number 2. So binary link is link which is connected to other link at 2 points. Same way, ternary link is the link which is connected to another link at 3 points, 1, 2, and 3. Quaternary link is a link which is connected to other link at 4 points, starting from 1, 2, right, 3, and 4. So binary, ternary, quaternary link is basically, it can be connected to how many other links at various points. That is what is described here. Moving ahead, guys, if I talk about reciprocating steam engine, then you can see here, this is my link number 1, which is cylinder. So basically, cylinder consists of parts such as engine cylinder, the frame, and the main bearing. This together becomes one link, which I'll call it as a cylinder. Same way, the crank, it consists of parts such as, you can see in the diagram over here, crank, crank pin, crankshaft, and the flywheel. Same way, the connecting rod basically is the parts like connecting rod, its small and big end bearings. Same way, piston consists of piston, piston rod, and the cross head. So these are the kinematic links, right? Why? Because crank is going to rotate. This is the part which is crank. It is going to rotate with respect to another link, which is connecting rod. So when the crank will rotate, the connecting rod is going to oscillate. Because of that, the piston is going to reciprocate inside the cylinder. This is how it is going to take place. Moving ahead, so I just wanted to show you how it works like. So basically it works this way, right? You can see the crank is rotating. Let me just interrupt here. This portion is my crank, right? This is connecting rod. This is piston rod. This is piston, right? And this is the cylinder. So you can see here, as the crank is rotating, the connecting rod is oscillating. The piston and piston rod are reciprocating inside the cylinder, right? So this is the IC engine mechanism, internal combustion engine mechanism. We are going to use this further in so many examples, right? But basically, I just wanted to show you which are the kinematic links. The kinematic links are crank, which rotates with respect to connecting rod. Connecting rod oscillates with respect to piston. Piston is going to reciprocate with respect to cylinder. So all these have some relative motion with respect to another part. That's why they are called as the kinematic link. Moving ahead, guys, you can see here the other three types of links are rigid link. Rigid link means the one which does not get deformed while transmitting the motion. Usually, there is no such body which is rigid body. Every body is going to get deformed. It is a law of nature. But still, this crank, connecting rod, they actually functions for years and years. The deformation observed is very negligible. So we always call these bodies as the rigid bodies. as compared to bodies like belt, ropes, chains, because they get partly deformed. So if the body gets partly deformed in such a way that they do not affect the required transmission of motion, because when they start affecting the transmission motion, we are going to replace it or we are going to tighten it. So these links are called as the flexible links. The fluid links, right, which you can see here, if I apply the foot pedal pressure over here, right, then because of that the brakes will be applied on the wheel. So this is the hydraulic brake which is shown. So the transmitting motion is happening through the help of the fluid by pressure or compression. So since the fluid is the medium of applying the brake, that's why I can call this link as the fluid link. So this was the classification of the links, the types of links. What are the different types of links? Moving ahead, next term is the kinematic pair, right? So this is also asked in the definitions. So that's why we are doing it. Now, see, how do I define kinematic pair? When two links, see this is link number 1 and this is link number 2. When two links are connected in such a way, I can call this link as 1 and this link as 2 or vice versa, right? When two links are connected in such a way that links show completely or successfully constrained motion, then the pair of links is called as the kinematic pair, right? So basically, if there is a one motion, constrained motion means only one and only one motion. You can see here, if this is the rectangular box, then inside this there is a rectangular part which is going to have only one motion, which is to and fro reciprocating motion. It won't have the rotary motion, right? It is not even possible. So if there is only one and only one constrained motion between the two links, then we can call it as a kinematic pair. Same way, if you see this diagram, right, two link is the fixed link. With respect to this fixed link, the link number 1 is going to just oscillate. There is no other motion that it can take. It can only oscillate. So since the links are connected in such a way that only completely one motion is possible, right, then we call it as the kinematic pair. I'm going to discuss what is completely constrained motion, successfully constrained motion, but since I'm going to discuss it later, for now you should remember that when the two links are connected in such a way that there is only one motion which is possible, not more than one motion, right, there is only one motion which is possible, then we will call it as the pair of the links, or we can call it as the kinematic pair. Moving ahead, I would like to show you with an example. You can see here one part is reciprocating inside the another fixed part. So there is only one and only one motion, reciprocating motions taken by one of the links, right? Then I can call it as the kinematic pair. Let me stop this over here and show you what I'm talking about. If I call this link number 1 and if I call this as link number 2, you can see here link number 2 is fixed, right? And link number 1 has only one and only one motion, which is reciprocating motion. एक से ज्यादा कोई मोशन ये सर्कुलर नहीं हो सकता और कोई मोशन नहीं ले सकता है ये. That's why we are calling it as a kinematic pair. So this was the animation to just show you, give you an example of what exactly is the kinematic pair. Moving ahead, degrees of freedom. See guys, what is degree of freedom? It is the number of independent coordinates, right, required to describe the position of the body. What I'm trying to say is that if we talk about this body, right, then this body can move, or say it can have linear motion in x direction, and it can rotate with respect to x direction. Same way, this body can move in z direction and it can rotate with respect to z direction. This body can move in y direction and it can rotate with respect to y direction. So these are the independent coordinates, right? Or these are the coordinates through which it can take motion. That's why we are calling it as the degrees of freedom. We are going to require this when we are going to classify the kinematic pairs. So I've included this over here. Moving ahead, guys, let's move ahead and see what is constrained motion, right? Since we defined it in kinematic pair, we said that when two links are connected in such a way that the links show completely or successfully constrained motion, then the pair of links is called as kinematic pair. Then what exactly is this constrained motion? Constrained motion means motion in a definite direction. Restricted motion, एक ही direction में motion अगर हो रही है, यहाँ पे लिखा हुआ है, if element or part has one and only one definite motion relative to another, then I can call that as the constrained motion. Because see, in machine parts, if the body is not fixed, it is just moving in one direction. But if it starts moving in more than one direction, then what will happen? It might be possible that the body might not function properly. I should restrict its motion in a particular direction only. Otherwise, its function for which it has been designed, that will not be fulfilled. So let us classify it. The classification of the constrained motion is that A, completely constrained motion, B, incompletely constrained motion, and C, successfully constrained motion, right? So we are going to see one by one all of them. Let us first start with completely constrained motion. See, it is a relative motion between the pair of links in one and only one finite direction, irrespective of whichever force is applied. मतलब एक लिंक सिर्फ एक ही डायरेक्शन में मूव कर रहा है विद रिस्पेक्ट टू अनदर लिंक, एक से ज्यादा मोशन डायरेक्शन में मोशन नहीं ले रहा है. अगर वो सिर्फ रेसिप्रोकेटिंग ही ले रहा है, राइट, अगर वो सिर्फ रोटरी मोशन ले रहा है तो सिर्फ एक ही मोशन ले रहा है. रोटरी प्लस रेसिप्रोकेटिंग अगर ऐसे कंबाइंड मोशन ले रहा है तो देन इट वी कैन कॉल इट एज द two directions. Motion is taken in two directions, which is not completely constrained motion, right? Let me explain you this with respect to one diagram. This diagram, right? This diagram number one, it is a diagram of rectangular bar. This is a rectangular bar sliding in a rectangular slot. This is a rectangular slot. Now you can see from the figure that this rectangular bar is one link and rectangular slot is another link. Let me give this rectangular slot as link number one and rectangular slot as link number 2. They have relative motion in only one direction. मतलब ये जो rectangular bar है ये सिर्फ slide कर पाएगा एक ही direction में. Only one definite direction it is having, right? It can only reciprocate, right? It cannot it can only slide. It cannot oscillate or rotate, right? That's why we can call this example as an example of a completely constrained motion. Same way ये जो दूसरा diagram तुम लोगों को दिख रहा है guys, right? इसमें भी क्या होगा? This shaft, right? Since it is fixed over here, right? It won't reciprocate. It will only rotate. So only one and only one direction is possible, right? One and only one definite direction is possible. So this is also an example of a completely constrained motion. और कौन से example हो सकते हैं? Suppose, right, this is one link and with respect to this there is another link like crank. तो एक ही motion possible है crank का, rotary motion. ये जो मेरा लिंक नंबर 1 है और ये मेरा लिंक नंबर 2 है क्रैंक, तो क्रैंक का सिर्फ ओनली वन डिफाइनेड डायरेक्शन इज पॉसिबल विच इज रोटरी मोशन, right? So this is also an example of a completely constrained motion. I'll show you this with one example again. So you can see here completely constrained motion. Let me show you in this diagram. This is the rectangular slot which is sliding in a bar. sorry, this is a bar which is sliding in a slot. You can see only one direction is there, which is linear motion. Same way, this shaft is only having one motion, which is rotary motion, right? It cannot reciprocate because it is fixed over here by the bars. So it can only rotate. So since the motion is happening in only one direction, right, we can call this example as a completely constrained motion. You can see in the diagram, in the first diagram, you can see that how one bar is sliding inside the slot. Only one motion is possible, which is sliding motion. Same way, in the second diagram, you can see the shaft is only rotating, right? It is continuously rotating, but it does not reciprocate. So only one direction is possible. That's why we can call this as a completely constrained motion. So if it is having a relative motion between the pair of links in only one definite direction, then we can call it as a completely constrained motion. Let us move ahead. Let us move to incompletely constrained motion, right? Motion between the pair of links in more than one direction. अगर लिंक एक लिंक किसी दूसरे लिंक के रिस्पेक्ट से एक से ज्यादा मोशन ले रहा है, then I will call it as the incompletely constrained motion. For example, you can see this diagram, right? A circular bar, ये जो है ये मेरा circular bar है with respect to a circular hole. This is my circular hole. So you can see this shaft can reciprocate also and it can rotate also. Two motions are there, more than one direction, right? The motion is happening in more than one direction. Reciprocate भी होगा and rotate भी होगा. So this is an example of incompletely constrained motion. It is the motion between the pair of links in more than one direction. Then we are going to call it as incompletely constrained motion. Let us see this again. You can see here, this is what I was showing. Circular bar inside the circular hole. You can see the shaft or the bar. It is reciprocating also as well as it is rotating. So since more than one direction is happening, right? So it is an example of incompletely constrained motion. Motion between pair of links in more than one direction is called as incompletely constrained motion. Moving ahead, guys, successfully constrained motion. See, when the relative motion between the pair of links is not completely constrained by itself, but it is made by some another means, then the motion is called as successfully constrained motion. Let us see one example. See guys, अगर ये यहाँ पे फोर्स नहीं लगता, ये एक शाफ्ट है, let me call this is link number 1 and this is the footstep bearing, let me call as link number 2. So अगर यहाँ पे लोड नहीं होता तो शाफ्ट रोटेट भी करता एंड रेसिप्रोकेट भी करता, बट राइट मतलब इसका मतलब है इट इज नॉट कंप्लीटली कंस्ट्रेंड, इट इज इनकम्प्लीटली कंस्ट्रेंड मोशन, क्योंकि दो मोशंस हो रही है, राइट? स्लाइडिंग मोशन भी हो रही है, टू एंड फ्रो मोशन, एंड रोटरी मोशन भी हो रही है. बट अगर मैं किसी अदर मीन्स से लाइक फोर्स, इफ आई अप्लाई अ फोर्स ओवर हियर, then the motion will be converted into one direction, right? So now I will call it as a successfully constrained motion. So when the relative motion between the pair of links is not completely constrained by itself, खुद से नहीं है, but I'm doing it by some another means, like I'm applying the load over here in this case of footstep bearing, then the motion is called as successfully constrained motion. Right? There are so many examples. See, if let us say that a keyway is provided in a circular shaft, right? Suppose there is a shaft over here, right? And if I want to restrict the motion, क्योंकि shaft दो directions लेने वाला है, right? The shaft, unless and until it is not properly tightened up, right? Then what is going to happen? The shaft is going to rotate also and it is going to reciprocate also. But if I apply a key over here inside the keyway, right? If I am going to insert a key in the keyway, Then if the key is provided in the keyway of the circular shaft moving in the circular hole, then it will prevent its sliding motion of the shaft. इसके बाद क्या होगा, शाफ्ट सिर्फ रोटेट कर जाएगा, वो स्लाइड नहीं कर पाएगा. सो द अदर मीन्स जो हम यहाँ पे बात कर रहे हैं, बाय सम अदर मीन्स, तो यहाँ पे मीन्स क्या होने वाला है, अ की इनसाइड द की वे. वो अपने आप से कंप्लीटली कंस्ट्रेंट मोशन नहीं है, बट हम किसी और मीन्स से उसको फिक्स कर रहे हैं, उसकी एक मोशन को कंप्लीटली रिस्ट्रिक्ट कर रहे हैं, और उसके बाद वो सिर्फ एक ही मोशन में रोटेट मतलब मूव कर पाएगा. Then because of that we are going to call it as a successfully constrained motion. So three types of constrained motion: completely constrained motion, incompletely constrained motion, and successfully constrained motion. Moving ahead, guys, I have discussed this degrees of freedom. Let's move to the kinematic pair definition again, because now you have seen the actual term, what is completely constrained motion and successfully constrained motion. So what is the definition saying? When two links are connected in such a way, isko link number 1 le lo, isko link number 2 le lo. When two links are connected in such a way that the links show completely or successfully constrained motion, ये लिंक्स या ये पेयर ऑफ लिंक्स के बीच अगर कंप्लीटली और सक्सेसफुली कंस्ट्रेंट मोशन ही हो, देन ओनली दीज पेयर ऑफ लिंक्स विल बी कॉल्ड एज द काइनेमेटिक पेयर. So for a pair to become a kinematic pair, they should have completely or successfully constrained motion between them. So let's proceed to the classification of kinematic pairs. Your university exam, the question is asked that classify kinematic pairs, or what are the different types of kinematic pairs. Then we are going to do the classification on basis of three main points. The first one would be the nature of contact between the elements, whether it is a line contact, point contact, or a surface contact. Then on the basis of type of relative motion between the pair, whether it is you can say whether it is a rotary motion or a rolling motion or screw pair, spherical pair, what kind of relative motion is there between the two links. And then the type of closure or nature of mechanical elements. On basis of this, it is classified as lower pair, higher pair, sliding pair, turning pair, rolling pair, screw pair, spherical pair, self-closed pair, and forced closed pair. Let us move with the first one, which says the lower pair. Now, what is the lower pair? A pair of links having surface or area contact between them is known as the lower pair. So I can say that when two links, let me call this as link number 1, let me call this as link number 2. When two links have surface contact, you can see this whole surface of theirs is in contact with each other. The two links, their surfaces are in contact with each other. And when the relative motion takes place, it is called as the lower pair. So I would like to again define it. When the two links have surface contact, when their relative motion takes place, it is lower pair. Now let the animation again start. So maybe you would get an idea of how the surface contact is taking place. You can see there, right? So what would be the other examples? Say automobile steering gear, the screw pair, turning pair, sliding pairs that we are going to see ahead. They are all going to be the lower pairs, because what is going to happen? The link 1 and 2, their surfaces are going to be in contact with each other when they'll be in relative motion with each other. Hence, they will be called as the lower pair. Moving ahead, the in the same category, that is based on the nature of contact between the pair, we are going to come with the second one, which is the higher pair, right? Now, what is the higher pair? When the two links have, say, point or line contact between them. When the relative motion takes place between those two links, it is called as the higher pair. So when a pair has a point or a line contact between the links, it is known as the higher pair. You can see in the diagram, the rolling contact bearings are shown, right? It is a clear-cut example of a higher pair. What would be the other examples? Sorry, let me go back to the slide again. What would be the other examples of the higher pair, right? The pair of gear tooth, right? The gears that mesh with each other, right? They are the examples of the higher pair. The cam and follower mechanism, right? That is the example of a higher pair. So, or you can say if the straight path is there and the wheel is rolling on a surface, that is also an example of a higher pair. The pair of friction discs, the belt and rope drives, the cam and follower, the tooth gears, the ball and roller bearings. These are all the examples of the higher pair. Again, why? Because I'll again say the definition: when the two links have line or point contact, when the relative motion takes place, it is known as the higher pair. Moving ahead, guys, to the classification based on the relative motion between the pairing elements, right? What is sliding pair? It is also called as prismatic pair, right? Extremely sorry, I should have written here the sliding pair or prismatic pair. So when the two links are connected in such a way, you can see here, this is link number 1 and this is link number 2, or let us say this is link number 1, this is link number 2. When the two links are connected in such a way that one link can slide relative to another link, the pair is called as the sliding pair. When one link can slide with respect to another link, then I'm going to call it as the sliding pair, right? Let me show you with the help of the animation which is there. You can see the degree of freedom is 1. Why? Because only one and only one relative motion is there, which is the sliding motion. So I'll again define: when the two links are connected in such a way that one link can slide relative to another link, the pair is known as the sliding pair. What would be the other examples of this, right? The other example would be, say, the cylinder and the piston, right? The other example, this is my cylinder and this is the piston. So the piston and cylinder in the reciprocating steam engine is a clear-cut example of a sliding pair, because what is going to happen? The piston is going to just slide inside the cylinder. The another example is this one. You can see the rectangular rod in a rectangular hole or rectangular slot. Again, one more, the tailstock, right, in the lathe machine. The tailstock on the lathe bed, that is also an example of a sliding pair, because you know the tailstock slides, right? Then the ram and its guide on the shaper, right? That is also an example of a sliding pair. Let's move to the another classification, right, which is the turning pair or revolute pair, right? So when two links, right, when the two links are connected in such a way, let me call this as link number one, shaft, right, and this is the link number two, bearing. When the two links are connected in such a way that one link can turn or revolve, when one link can turn or at it can revolve relative to another link, right, then I can call such pair as the turning pair or revolute pair. Let me let that animation be seen on the screen correctly, so you will get an idea. You can see here the shaft is rotating, revolving, turning relative to another link which is bearing, right? So this example which is shown, this one, is actually the example of shaft revolving inside a bearing. What could be the possible other examples? Suppose if this is a crankshaft, right, with respect to one fixed link, right, then you will see that the crankshaft also revolves with respect to the fixed link, which I'm going to call it as a frame. Then this is also an example of a turning pair or a revolute pair. The wheel turning over their axle is also an example of a turning pair. The lathe spindle supported in the headstock, that is also an example of a turning pair or revolute pair. Moving ahead with the third one, right, which is rolling pair. You can see the belt which is there on the pulleys, right, or the rolling bearings. This is an example of a rolling pair. So when two links are connected in such a way, this is my link one number one, which is the pulley, and this is my link number two, which is the belt. So when two links are connected in such a way that one link rolls, one link rolls over another link, then such pair, I'm going to call it as the rolling pair. What would be the possible examples? The ball and roller bearings, you can see over here, the motion of the belt on the pulleys. These are all in examples of the rolling pair. Moving ahead quickly with the another fourth type of pair, which is the spherical pair. You might have used the joystick for playing games, right? This is an example of a ball and a socket joint. You can see when one link in a form of a sphere, right? You can see the ball element is a sphere. So I'll define the spherical link or the globular pair. It is also called as a globular pair. So when one link in the form of sphere turns inside a fixed link, it forms a spherical pair. I'll again repeat, when one link in the form of a sphere turns inside a fixed link, it forms a spherical pair. In the animation, you can see the ball element, it turns 360-degree, right? It forms, it is actually forming a sphere and it turns inside the fixed link. So I'll call it as the spherical pair. What would be the possible examples of this? The one is written over here, the ball and the socket joint. The second one I already told you, that when you play video games, you use the joystick, right? So the joystick of video games, that is an example of your spherical pair. The third one is very practical one, the actual engineering example, the attachment of the car mirror, right? The car mirror, the attachment of the car mirror is a clear cut example of a spherical pair. The pen stand, right? The pen stand, that is also an example of a spherical pair. Moving ahead to the last one of this classification, based on the relative motion between the pair, is what is called as the screw pair or the helical pair. The screw pair or the helical pair. So when the two links, obviously here the two links are the nut and the screw or the bolt, the two links are connected in such a way that one link can turn about another link by screw threads, then the pair is called as the screw pair or the helical pair. And the nicest example of this is the one which you are actually seeing in the diagram, which is the screw and the nut. Practically, where is it used? The lead screw and the nut of the lathe machine. That is the screw pair. The bolt and the nut which you are seeing. The C clamps. In your workshop, you would have seen the C clamps, the vices, fitting vices, right? They are all the examples of the helical pair or the screw pair. Moving ahead, guys, to the classification based on the nature of constraint, mechanical constraint. And the first one is the closed pair. It is also called as the self-closed pair, right? So when the pair of links are held together, you can see the two links, the pair of links are held together mechanically in such a way that only required kind of relative motion occurs. यहाँ पे required kind of motion which is there, that is our uh, sliding motion, right? And that's the only motion which is possible, and that is happening by its own, right? So when the pair of links are held together mechanically in such a way that only required kind of relative motion occurs, they form a closed pair, or better to say self-closed pair. All the lower pairs, sliding pair, turning pair, screw pair, right? Sliding pair, turning pair, screw pair, they are all self-closed pairs. Moving on to the last of the classification is unclosed or forced closed pair. You can see the cam and follower mechanism. When the two links are not held together mechanically, right? यहाँ पे देख सकते हो आप cam rotate कर रहा है. कभी कभी what happens? Sometimes the follower will be stuck at a certain position. It will not come down on its own. Then I am forcing it to come down with the help of the springs. You can see the spring, right? So it is not the self-closed pair. This is the unclosed pair or forced closed pair, because the spring is going to bring the follower down. Sometimes it gets stuck if the spring is not there. So I'm forcing the follower to come down with the help of the means, which is spring. Hence, I'll call it as the unclosed pair or the forced closed pair. So how to define this? When the two links are not held together mechanically, but are kept in contact by action of external forces like spring over here, the pair is said to be forced closed pair. The cam and follower is an example of this. You can see this, right? Because the cam and follower are held together by forces exerted by the spring or gravity only, right? And not mechanically. So this was the classification of the kinematic pair. Moving ahead, the next term, or say the next definition which is asked in your university exam is kinematic chain. So kinematic chain is actually a combination of kinematic pairs in which each link forms a part of two kinematic pairs, and the relative motion between the links is completely or successfully constrained motions. So this is an example of the kinematic pair. You can see here the connecting rod, right? It is one pair is crank and connecting rod, the other pair is piston and connecting rod, right? So what I'm trying to say is that the definition says that each link forms a part of two kinematic pairs and the relative motion between the links is completely or successfully constrained motion. Then I'm going to call it as the kinematic chain. So if the kinematic pairs are coupled in such a way that last link is joined to the first link to transmit completely or successfully constrained motion, then it is called as the kinematic chain. The simplest example is shown in the diagram, which is a single slider crank chain mechanism, the IC engine mechanism, right? Where the frame is connected to crank, right? The crank link 2 is connected to link 3 connecting rod, and connecting rod is connected to slider, and again in turn, right, the slider or say our cylinder is actually connected to the frame. Hence the pair of links form the kinematic chain since the last link is joined to the first link. Moving ahead uh, to another definition which is called as structure, right? Structure is basically a locked chain. You can see the diagram. The better definition for the structure is that the links are connected in such a way that there is not going to be any relative motion between the pair of links. They are always going to remain fixed. They are locked. Hence, we are going to call it as the structure. Now, what is actually structure? Structure is an assembly of number of resistant bodies without any relative motion between the links. They are just meant for carrying the loads. Structure does not transform available energy into useful work. It does not transform motion. It does not transmit power, right? They just transmit forces. So the purpose is to just transmit forces. This is structure. Moving ahead, what is a mechanism? Mechanism is a motion transforming device. So we had already seen kinematic chain. When one link in the kinematic chain is fixed, the arrangement is called as the mechanism. Let us take an example of the 4-bar mechanism, right? This is how the 4-bar mechanism is there. This is the link which is crank. This is the link which is connecting rod. This is the rocker or lever. And here there is the fixed link which is frame. So if there is no fixed link in this, the mechanism won't take place. So when one link of a kinematic chain is fixed, the arrangement is called as the mechanism. Mechanism is a motion transforming device. It transforms motion. Any mechanism is not called mechanism unless and until it is not clear which link is the frame link, which is the fixed link, right? So when the frame link is specified in the kinematic chain, I can call it as the mechanism. So if someone tells you what is the difference between kinematic chain and mechanism, in kinematic chain, you can see the definition of the kinematic chain was that a kinematic chain is a assembly of kinematic pairs in which one link or say each link forms a part of the two kinematic pairs, and the relative motion between the links is completely or successfully constrained motion. But till then we had not defined which link is the fixed link. So when the frame link is specified in the kinematic chain, it becomes the mechanism. And the two main mechanisms of our syllabus are the single slider crank chain mechanism and the 4-bar crank chain mechanism. The 4-bar mechanism and the single slider mechanism. Let me here only explain you what I'm trying to say. This is my crank which is going to rotate. It is rotating with respect to this fixed link frame, right? So when crank rotates, connecting rod is just going to oscillate, and because of that, that piston or the slider ram, the slider is going to slide and on the fixed link itself. Same way, in the 4-bar mechanism, the crank is going to rotate with respect to this fixed link number 1, which is the frame. Because of that, this connecting rod is going to oscillate, and because of that, this rocker or lever arm is also going to oscillate, right? So basically we also have to understand few definitions over here, right? Few words which I used, you should be aware of those words, because if the definition is asked in your university exam, you should be able to name this link which I am continuously talking about. I am talking about the word which is the word which is called as crank. Crank is that link, right, that rotates completely about a fixed axis. You can see this, right? So link that rotates about the fixed link, that I'm going to call it as the crank. Input link or driver, right, which is the input link, then the part of mechanism which initially moves with respect to frame link. यहाँ पे हमारा crank जो है वही तो हमारा input link है, that is only our driver, right? Because it is that part of mechanism which initially moves, which initially moves with respect to our fixed link, which is this one frame. Next in the definition is this lever or rocker link. What is that rocker or lever? It is that link that oscillates. The motion of rocker or lever is always, sorry, the motion of the rocker or lever is always the oscillation motion. So it is defined in such a way, the rocker or lever is that link that oscillates with limited angle of rotation, limited angle of rotation about a fixed axis. So it is also moving with respect to frame. Next in this category is the output link or follower, right? So the link from which required motion or forces are obtained is going to be my output link. In this case, the single slider crank chain, the output link is going to be the slider. But in the 4-bar mechanism, the output link is going to be the rocker or lever. So the slider we have not defined. What is the slider mechanism? We are going to use this word for the link which slides. So the link that forms a sliding pair with one link and turning pair with another link. That is going to be the slider. You can see here the slider slides with respect to this, but with respect to connecting rod, it is forming the turning pair because the connecting rod is going to turn, right? And when the connecting rod turns, the slider is going to slide. So the link that forms a sliding pair with one link and turning pair with another link, then it is going to be called as a slider. We have to call this link number 3. I usually call it as a connecting rod, or sometimes it is also called as the coupler. So coupler is that link which is not directly connected to frame or fixed link. You can see here it is connected to crank and here it is connected to slider. Let me rub this and nicely show you. We are talking about our link which is coupler, link number 3. How to define that coupler link? The link which is not connected to the fixed link or frame. You can see here it is connected to crank and here it is connected to slider. Same way here it is connected to crank and here it is connected to rocker or lever. So the link which is not directly connected to frame or fixed link is called as the coupler link, right? So you should be able to define the links which are crank, coupler, rocker or lever, slider. I'm again going to define all of them. Crank is that link that rotates completely about a fixed axis or the frame. Lever is that link which oscillates with a limited angle of rotation about the fixed axis, which is the frame. Coupler. Coupler is a link which is not directly connected to frame or fixed link. Slider. Slider is the link that forms a sliding pair with one link and turning pair with another link. So we were talking about the two main mechanisms which we are going to see in detail, study in detail, and see their inversions as well, right? So those two main are single slider crank chain mechanism and the 4-bar mechanism. So this is a single slider mechanism. We have already seen its video way back when we were seeing the definition of the link itself. The next in the race is machine. Machine is the collection of mechanisms which transmit motion and forces, right? So, machine transmits motion and power. So I can say the power transmitting device, the motion and power transmitting device is called as machine. So a machine transforms motion. When such a motion is used to transmit power, it is called as machine. हम ऐसा बोल सकते हैं कि a mechanism transmits motion, but when a mechanism is also used to transmit power, it is called as machine. So machine not only transforms motion, but it transforms available energy to do useful work. So power is the ability to do the work, you know that, right? So if the transmission of available energy to do the useful work is there, then we can call it as the machine. Machine is basically the assembly of mechanism. You can see that it's collection of mechanisms. Various mechanisms are used to transmit the motion and forces both. Now, there's one very interesting statement. Though all machines are mechanisms, all mechanisms are not machines. And I can easily prove this with the help of these two examples. This is a drafter mechanism, right? and these are the gears which are used in the machine, right? So obviously this is the gear mechanism which is used, right? It is going to transmit both motion and power will be transmitted, right? Because the gear drives are the power transmission devices, right? They transmit both motion and power, but the drafter is not going to transmit power, it is just going to transmit the motion. So I can say that this is the mechanism. Gear is also mechanism and it is the machine as well. So you can say all machines are mechanisms, but all mechanisms like drafter, they are not machine. Drafter is not a machine, it is just a mechanism. So all machines, any machine, take any machine, it is a mechanism. But all mechanisms like drafter, right, they are not machines. Moving ahead, guys, we want to still go deep down into the differentiation between the machine, mechanism, and structure, because that is what is asked in your university exam. That what is the difference between machine, mechanism, and structure? Before that, right, let us go to one more term, which is inversion of mechanism. See, what is mechanism? Mechanism is the one in which one of the links of the kinematic chain are fixed. Kinematic chain की किसी एक लिंक को फिक्स्ड कर दो तो वो बन जाता है mechanism, right? But different mechanisms can be obtained by fixing different link every time. Instead of fixing the same link, if I fix another link in the kinematic chain, then different mechanism would be obtained. These are called as inversions of mechanism. So inversion can also be obtained by adding one of the links in the existing mechanism, right? That we will see when we will see the beam engine mechanism, which is one of the inversion of the 4-bar mechanism. Let's see in short what we have studied till now. We have studied that the link is a resisting machine body. Kinematic pair is actually the joint of two links with constrained motion, either completely constrained motion or successfully constrained motion. Kinematic chain is the network of links, or it is, you can say, the when the kinematic pairs are connected with each other, they become kinematic chain, and they also have constrained motion. When one of the links of the kinematic chain are fixed, it becomes mechanism. And mechanism just transmits motion. But when it starts transmitting power also, we will call it as the machine. Or you can say that the mechanism that transmits motion as well as power, we will call it as the machine. So in short, whatever we studied till now, everything is covered this in very short nutshell. You could understand this. Moving ahead, guys, before I move ahead to the inversions of mechanism, I would actually like to show to you or explain to you one of the questions which is asked in your university exam, which is the difference between structure, mechanism, and machine. How do we define it? The structure is an assembly of number of resistant bodies without any relative motion between the links. So when there is no relative motion, it becomes structure. They are just meant for carrying loads. Mechanism. What is mechanism? When one link of the kinematic chain is fixed, it becomes mechanism, and it is the motion transforming device. In structure, you saw there is no motion, but mechanism is actually the motion transforming device. Machine is also a motion transmitting device, but it also transmits power. So machine is a mechanism which transmits and transforms both motions and forces. It transmits power as well. Hence we call it as the machine. What about the relative motion? Here we already told you that the parts of structure does not have relative motion since it functions purely on the basis of the forces that are going to act on it. It is meant to just carry the loads. Links of the mechanism move relative to each other. They transmit motion. Parts of the machine also have the relative motion between them. They transform the motion as well. In fact, they transmit or transform work and energy as well, right? So relative motion between the parts, on basis of that we have done this differentiation. What about transformation of energy? No transformation of the available energy into useful work is done in structure. No transformation of available energy into useful work is also done in mechanism, because mechanism is just the motion transforming device. But yes, machine transforms available energy into useful work. What is the purpose of structure? To transmit forces only, to just take up the loads which are coming on it. What is the purpose of mechanism? It is a motion transforming device. It transforms motion, transmits motion. Machine transmits both power and motion. Which branch of theory of machines does it deals with? We have seen in the initial video itself, and during the start of the lecture itself, we have classified theory of machines basically into two parts: kinematics and dynamics. And dynamics was further classified into statics and kinetics. So statics is the field which deals with the study of structure. Kinematics is the field which deals with the study of mechanism. And kinetics is the field which deals with the study of machine. What are the examples of structure? Bridges, roofs, trusses, building, an antenna mast. These are all examples of structure. Engine indicators, clock, typewriter, mechanical drafter. They just transform the motion, hence they are the motion transforming devices. Lathe machine, shaper machine, these are all examples of the machine.